Imagine a world where food waste is not a problem, but an opportunity. A world where leftover scraps are transformed into delicious and nutritious meals. This might be possible thanks to a special fungus called Neurospora intermedia. Vayu Hilmani is a chef-turned-chemist who is passionate about using fungi to reduce food waste. In his research, he has been studying a traditional Indonesian process where people take food waste from soy milk.
What I've done is actually studied a traditional process in Indonesia where people take food waste from soy milk and make a delicious meat substitute called oncom. We uncovered this fungus called Neurospora intermedia. You can see it here growing in a petri dish. And what we learned is that this fungus has a unique ability to grow on a lot of different wastes from the food system.
Versatility makes Neurospora intermedia particularly interesting. The process begins when food waste, such as soy pulp, also called okara, is placed in a controlled environment where Neurospora can grow. The fungus breaks down the waste, feeding off the nutrients, and in the process, increases the protein content of the substrate. Every year, tons of food go to waste while millions struggle to find nutritious meals. Hilmani wanted to change that. His goal? To create a system where waste is not discarded but transformed into something valuable and nutritious. The collaboration between science and the culinary world is already taking shape. In fact, Vayu Hilmani and his team have begun working with several chefs to explore the potential of Neurospora intermedia in real-world kitchens. Notably, Michelin-starred chefs have expressed interest in incorporating this sustainable ingredient into their menus.
One of the key things, I think, for me, having worked in food and in cooking, is that how do we make sure that these discoveries don't just stay in the lab? Chefs are cultural voices in food. So if we can take our findings and research and work with those people, I think we can unlock some really new, exciting possibilities.
Through rigorous experiments, Hilmani's team tested the ability of Neurospora intermedia to grow on various types of food waste. The transformation doesn't happen overnight. It typically takes several days for the Neurospora to fully ferment the food waste. In their research, Hilmani's team experimented with different durations and conditions to optimize the process. Remarkably, not only could the fungus thrive on what would otherwise be discarded, but it also enhanced the nutritional profile of the substrate it grew on by 20%. This breakthrough moment revealed a potential new food source that could help feed the world while addressing sustainability concerns.
So we analyzed it in molecular detail. We looked at, does it produce any known mycotoxins? Mycotoxins are toxins that are produced by fungi that can have detrimental health effects. We did not find that Neurospora had a capacity to make any such toxins. And so from that perspective, it should be safe. We also looked at the nutritional value. What might this fungus do to the substrate that it grows on? And we found that the protein content actually might increase depending on the substrate. So you're getting a nutritional boost. And then finally, the sensory attributes. How do people perceive the texture, the flavor, and the appearance of the food?
The researchers also ran sensory tests to evaluate the taste, texture, and appearance of the resulting food. Their findings showed that the fungal fermentation not only improved the nutritional value, but also imparted savory, umami flavors, making the final product more palatable and delicious. Based on his research, Vayu is confident that Neurospora intermedia has the potential to be a promising solution to food waste. He envisions a future where food waste is seen as a resource, and Neurospora intermedia is used to create delicious, nutritious, and sustainable foods.
With that data and the historical long process of consuming and using Neurospora, we are confident that this might be a promising solution moving forward. My long-term vision is really to look at these large kind of waste streams that come out of our food system. Look at them as an opportunity, as an ingredient in and of itself. Why does it have to be called waste?
One of the most promising aspects of this research is the wide variety of food waste that the Neurospora intermedia fungus can grow on. In their studies, the research team primarily focused on soy pulp, a byproduct of soy milk production, and tested it extensively. However, they didn't stop there. Other agricultural byproducts like fruit peels, corn husks, and coffee grounds were also explored. In fact, the team experimented with over 10 different types of food waste, finding that the fungus could thrive on many of them.
I hope one day you go to the store and you have your meats and you have your tofu and maybe you have your Neurospora foods as one of the alternatives and one of the options that are available to you that are tasty, they're nutritious, and they also happen to be made in a very sustainable and circular way. The fungus really kind of binds it together. It makes it more savory, more umami. It's just a delicious piece of food.
1.3 billion tons of food waste produced globally each year could be transformed into savory, nutritious foods. The only question is whether we will be ready to embrace food made from what we used to throw away. Only the future will tell. The future that sends us an illusion through the time mirror.